Okay, now we understand what a sine graph looks like. It started here, it went up to 1, came to 0, came down to -1, and went back up to 0. And so you could kind of see the sine wave, as they call it. Okay, and then do I want to put cosine on the same one? Probably not. I'll put cosine underneath. Y is equal to cosine x. It starts at 1, comes down to 0, goes to -1, back to 0, back to 1. So it really looks just like a V, if you will. Fancy V. That's what it looks like, for the most part. The cosine graph. Okay, so we have sine and cosine. Well, there are certain points that we really need to know about sine and cosine. And so I'm going to do them just up here. Maybe I'll just use the graph as part of the paper. X and then sine of x. Okay, at 0 degrees, we've got 0. At 90, we've got 1. At 180, we've got 0. At 270, we've got -1. And at 360, we've got 0. These are important points you're going to need to know. And I'll do cosine in the middle here. X and then cosine x. I'll put 0, we've got 1. I'll put 90, we've got 0. 180, we've got -1. 270, we've got 0. And 360, we've got 1. These are important points that we should always know. These are the parent graphs. Okay, the mother functions, whatever. These are parent graphs. Well, today I'd like to look at sine. And you guys are going to look at cosine in a moment, and I'm going to have you do one of the cosine ones, but it's the same stuff on all graphs. When we talk about y equals x squared, okay, sidebar, we knew this with the mother graph. We went here, went to the right 1, up 1, right 2, up 4, right 3, up 9, because we were squaring, and we knew we had a mirror image, and that's awesome. Okay, so we've got our little parabola here. I have a question. What happens when I do this? What was, anyone remember what we called that, what that did to the graph? 2 words that I'm looking for. If it's greater than 1, if it's less than 1, but also greater than 0. Because if it's less than 0, it tells us it reflects and points downwards. But as long as this is positive, if it's greater than 1, what does it do to the graph? Anyone remember? Those are the fancy dancy words I'd like to hear. Someone say it. Free homework. IHOP right here. You can earn an IHOP. What are the 2 words I'm looking for?
Is it stretch and compress?
Oh, who was that?
Addison.
Yes, it is. Thank you, Addison. You got that. Addison got the IHOP. Stretch and compress. Well, guess what? Does the same thing for sine. Okay, so I'll go ahead and put my sine graph up here, the mama graph. And I'm going to write y. I wonder if I can fit it up here. I'll just fit it down here. It's fine. Y is equal to 4 sine of x. Well, what it's going to do is take the table of values. I'm still going to put in a 0 degrees. Well, 4 times sine of 0. Well, sine of 0 is 0. We know that. So it's going to be 4 times 0. Well, that's still 0. Okay, so basically it's going to take this column and multiply it times 4. So at 90 degrees, I'm going to have 4 times the sine of 90. Well, the sine of 90 happens to be 1. 4 times 1 is 4. Okay, and I'm going to graph this. I've got some graph paper here. And I'm going to call this a 1 now, because I can't do it on that paper. 2, 3, 4, -1, -2, -3, -4. Works for me. I will draw the sine graph first. We start at 0. We go to 1. We go to 0. We go to -1. So it's just I just adjusted the scale. Okay, so there's our mama graph. Y equals sine x. Now I'm going to use a different color. I'll use pink to do y equals 4 sine x. Well, at 0, it's still 0. At 90, guess what? Instead of being at 1, it's up at 4. So here at 0, it's still 0. 4 times 0 is 0. Here at -1, it'll now be at -4, and then it'll come back to 0. I could do all of the table of values. I don't know if it's actually necessary. Okay, here's the mama graph for sine x. I guess I should put those on here. X, sine x, 0, 0, 90, 1, 180, 0, 270, -1, 360 is 0. This is the table of values for this. This is its graph. All I'm going to do is take 4 times all of these numbers, and that's where we get these pink dots from. So now I'm going to connect the dots. That's not that pen. Where is it? Here it is. Here we go. Perfect. Perfect. Okay, so you can see all it did was take this graph and stretch it. If I had done 1/2, it would have just made it half as much. It would have flattened it. Okay, it would have compressed it, pushed it down. All right, so today we're going to learn about the number out front, stretch or compress. And then this is called the amplitude. I don't really care if you know what it's called. Absolutely don't. The next one we're going to learn about, I'm pretty sure it's called the period. But to be honest, I'm not 100% sure on that. But we're going to try it anyway. Okay, so now I've done 4 sine of x. Well, guess what I want to do now? Different color. I don't know if you can tell this is orange. Okay, let's go with green. I think you'll be able to tell it's green. I want to try this. Y is equal to sine 4x. Okay, here's the difference. Okay, when it's in front, if it's a number in front, it's called the amplitude. And it talks about stretch or compress. Meaning we're only going to have one sine wave between 0 and 360. Now this one, I'm pretty sure they call it the period. And this is how many number of sine waves or cosine waves in one 360-degree rotation is what I'm going to call it. But think about it, from 0 to 360. In this area, that number tells us how many sine waves. This is one sine wave. So that 4 should be telling us we're going to have 4 sine waves in here. In fact, I'd like to do let me do the 4. It's fine. Okay, so I'm going to take the table of values. And this is where it gets a little tricky. X sine 4x. And then I'm going to say what y is. Okay, so if I put a 0 in, let me zoom in on just this part. Okay, if I put a 0 in, 4 times 0, I still have sine of 0. Well, that's perfect. Sine of 0 is 0. Okay, if I put a 90 in, and I'm giving myself some room, you're like, why is she giving herself so much room? Well, what's 4 times 90? I believe it's 360 degrees. Okay, so I look at 360 degrees and the sine is 0. Well, that doesn't help me a whole lot because now I have this point, and at 90, it says I have a 0. At 90 degrees, I put in a 90, but because then it says 4 times. Oh my goodness. Sounds good. Oh, I'm okay with that. All right, we'll ask Sam. Sorry. Okay, the next number is 180. But when I get to 180, well, what's 4 times 180? Hell, I don't know. 0, 2, I get 720. So it's the sine of 720. Well, I don't know. I have to think about a unit circle now. On 720, let's see, 0, 360. Oh, it's right here. So it's going to be the same as sine of 360. It's also a 0. Okay, so I got a 0. So far, I have no idea what's happening on this graph. I'm going to have to pick some numbers in between. Okay, I can continue, and I'm going to. I'm going to go ahead and do the next one, 270. Sine of, well, 270 times 4, 1,080. Man, 720, 810, 900, 990, 999. Oh, right here, 1,000. Oh, we're right back here. It's sine of 1,080 is what we're looking for, and it's 0. What are the friggin' odds of that? I don't know. It's kind of everything. I called a hunch that 360, when I put it in, I'm going to get sine of 1440, which this happens to also be. They're coterminals, guys. They're all here. Okay. Now, I definitely need to know what's happening in between. So let me pick. Oh, here's a good idea. Why don't I take these values and see if any of them divide by 4? Does 4 go into 180? It does. Let's pick 45 degrees. Here's why. Sine 45 degrees, 45 times 4 is 180. Oh, good. What is sine of 180? It's also 0. So at 45 degrees, where that would be in here, is 0. It's going to cut through there. Halfway between these two. Halfway between these two, it's going to cut through there. Halfway between these two, you'll see a pattern. Well, I need to know, where's it going to be 1? I need to get, okay, what's 90 divided by 4? Don't know. Twice. It's like 22.5 degrees. Who would ever think of that? So it's going to be halfway between here. There's my 1. Halfway between there. There's my 1. There's my 1. There's my 1. There's my 1. It's going to be much easier if you had different number there. But you kind of get the idea. Halfway, whatever. Okay, watch what's going to happen. There's 1 sine wave. That's 1 sine wave. There's 2 sine waves. There's 3 sine waves. There's 4 sine waves. You're going to have this green line represents y is equal to sine 4x. It tells me I'm going to have, and 1 sine wave, technically, when you look at it, here's a sine wave, from 0 to 360, it's 1 up and 1 down. So here we have 1, 2, 3, 4, all within from 0 degrees to the 360 that's over here. There will be 4 sine waves. That's called the period. That is all we're doing today. Let me stop sharing.